Hi everyone, I'm Mårten Ericson, working in Ericsson Research and work package lead for the 60 architecture design work package in Hexa-II. So the 60 architecture design, I think this is a little bit continuation. We work together a lot with Sylvain's work package. It's also about architecture and other stuff, but we are the one having architecture in the name here, but we're not the only one doing it. We have 5 different parts in this work package. I'll try to point here. Could have. So it's AI enablers and data-driven architecture. We have new access methods and flexible topologies, more mobility issues. We have network beyond communication, new services like sensing. And then we have 2 architecture tasks, I usually call them. One is this network modernization. It's a more traditional look into how to improve the signaling and the network functions, composition, and so forth. And the same also for the cloud transformation, how to transform the cloud to telco-grade. So I will go through the enablers of these, not all enablers actually. We have limit too many to present here, but many of them here in a quite fast pace. But that hopefully gives you a little bit favor what we are doing. So there is currently no solutions yet. It started up. So this is last year's probably definitions, and say a little bit more than that of our work. And I'll start with the AI enablers, data-driven architecture. And the MLOps is the first enabler here. MLOps is then ML operations. And here we're working to have the management system, basically, how to place the different ML operations, ML agents all over the network in a smart way. Privacy data collections and so forth. And going then to the data collection is also a separate enabler called DataOps. So they work together with the MLOps, of course. So the question here is, how do you select the data? What data sources are you using? How do you put in the data back in the network again? And how do you store it? How much should you process it and so forth? And to which applications should you send these to? What ML operations should you send it to? So this has a rather big impact. This could be then, of course, continuation of what you have in 5G, but it could be also new protocols and functions we are thinking about here. Then, of course, to this is then all other protocols needed for. We have also the APIs to expose it to the end users. There could be other functions and so forth. We could say that we are here right now. We do have AI in 5D also, of course, it's not complete. So we have to build on that and do this in an incremental step. So we make sure that it's not, everything will be right here to have this data-driven information here. So we trying to look into different types of protocols and interfaces needed to handle this, and also the APIs, of course. And finally, we have the AI as a service, and that's basically the combination of all of the previous enablers. So that will then create this puzzle game here as a service, maybe everything together. And this figure is also showing that this AI as a service is taking this is then how to train the ML operations, how to monitoring, and how to store them and so forth. And that you have they should work in different types of deployments or domain. Here's the edge cloud and the cloud. They should still be synchronized. So you have to handle that also. That was about this task. Let's go on to network modernization, which is then the architecture, most of the pure architecture task, perhaps you could say. The objective here is then to have a look at the different network functions all over the network and how they can be streamlined, and how the network functions will be modularized to make them the system or the architecture more streamlined. And the first enabler is actually called the network modernization. Very nice. And here we look into more of the focus on the network functions compositions and how granular should they be. Should it be very small entities or very bit larger functions? Comparing that what we have in 5G also to see if we can improve what we have in 5G. We try then to enhance the latency and increase the energy efficiency also, of course. This is a big impact on if we want to do any change. It has a big impact on the standardization. So here's one example. For example, instead of doing this service-based architecture, we do procedure-based network functions approach here. Looking into this is better or worse. Going then to next is then the end-to-end design enabler. And this is the enabler that takes the modernization enabler we had previously and see how can we deploy that in the end-to-end perspective. Looking into more end-to-end perspective, or how can we improve the signaling when we have this modular design. One good example of this is then this slicing concept that we instead have meta slices or something. Instead of having these monolithic slices where in 5G, we could maybe do something different where we customize the modules per slice. So have a different type of slice. It doesn't have to be the whole network. It can be part of the networks. So that's one way to use this modular design. Another one is also to have a look at for could this work for maybe more to the interfaces questions, how this work with self-MIMO and distributed MIMO is also something we look into together with other work packages. Then going to the third task, new access and flexible topologies, which you could say is the mobility or resource management task. And the first enabler we have is called network of networks. This was also used in Hexa-I, and that's a concept that we've defined that the network consists of many smaller networks, maybe called subnetworks in many cases. So satellites could be a subnetwork if it's a normal network. And then we could have a mesh network down here consisting of different devices talking to each other. They could be apps or drones also, like could be another subnetwork. And together this creates this what we call networks and networks. So we try to have as much as unified solutions so to handle these networks and networks. But we also look into specific details how they should work. One of the subnetworks we look into is this what we call management node that takes over some responsibilities from a base station to handle low capability devices, for example. Another subnetwork we look a little bit to it is architecture of the satellites, but we are not the satellite project, so we will have other presentations for far more detailed presentation on satellites. But we also look into that to some extent. And we also look into, in this task, we also look in the multi-connectivity area. Why this enabler should say this is to increase the coverage. But we also would like to also simplify in some ways. It's not always easy to do both, but we try to do that. And this one, the multi-connectivity is then more robustness and increased throughput, maybe more robustness than increased throughput, but it can be both. But you see the figure is almost the same, but now we look into how can we use multi-connectivity for this type of networks here too. For example, can we have the end-to-end and terrestrial network integration is interesting. How should that work? And of course, we're trying to evolve the dual connectivity aggregation solutions we had in 5G and see if we can improve them for 6G to make them more efficient. We also look into multi-route connectivity with 6G and Wi-Fi access here also. There's some activities going on here. Finally, we have something called the context awareness management. And this is where some of the layers should be aware of what type of service that so they can handle it, so can optimize the transporting the data in a better way. One good example is maybe this to the left here, that the transport network between the RAN and the core network, if we try to find ways to include quality services for the services running over this transport network, and then thereby maybe we can optimize it and save resources by doing that. Another example is something called the delayed compute paradigm. This is about the compute server. You have a server here for computing, but not everyone can use that. So by using a price mechanism for the users, you introduce delays and these price mechanisms to optimize the usage of this compute layer. And then we go to what we have, this network beyond communications. This is the new services for 16, we think. The AI is also new. But here we talk about sensing and compute, basically. That's the two services we focus on. And sensing, most of you know about that, trying to have sensing in all nodes and devices for 6G. And the first enabler we have is how to expose this to the end users, how to collect the data. It's a little bit similar to AI as a service. How do you process the data? Or should you process the data, or should you just send up the raw data to the end users? So what type of functions are needed for that? Here you see this figure also. So this data domain trying to collect the sensing data or compute data. Maybe it's mostly sensing data here, but here's everything. And then try to expose that in some way to the end users here. Very briefly explain. And another enabler we have is protocol signaling for both sensing, JCAS, and compute. They are a little bit different, so we treat them differently actually. So even though it's the same enabler here, this is not, for example, compute. It could be protocols how to discover there is a compute node that you can use for offloading your applications. And sensing, of course, is there's a lot of protocols might be needed for sensing, how to send the data from the sensing UI up to the base stations and further on to some sensing processing functionalities and so forth. So there would be new measurements needed, protocols, how to collect data and so forth. Here's an example just to show you how do you send out this information that you can sense certain vehicles or objects in a traffic situation. How do you present this to the end users? Just show an example. And here's the offloading. So this is the example of no offloading. So the device has some applications. So how does the device know when you can offload to the network? So these are the questions we're working with. Then the final task is virtualization and cloud transformation. So as I said earlier, this is one of the architecture tasks. So this is how to improve the underlying architecture and have the new services and use cases. But here focus on cloud and how to transform the cloud to telco needs. And the first enabler is maybe with the longest name, integration and orchestration of extreme edge resourcing, computing continuum. A computing continuum is then something, a definition is basically that all resources across the full network. And it also includes the UI. So maybe that's why we call it compute continuum, that all cloud resources that is also including UI that can be managed here by the network. So this enabler is mainly looking into how you can include maybe also to manage the UIs here to extreme edge, as it's called here. And to the benefit could be that we have better use of the resources in this compute continuum. So here's a figure here. So we have the extreme edge. This is end users to have maybe the edges and then the cloud here. So this goes into all integration of all resources here. And the final one is then something called multi-cloud federation enabler. So this is both the multi-cloud is then to aggregate the cloud services from different domains. It could be private clouds, it could be public clouds, or hybrid clouds, or whatever. So this is usually right now a little bit handled differently, and that it's a little bit complicated, of course, that you have to manage that in a separate cloud. So we here with the ideas to try to have a coherent management multi-cloud. Not only that, it's also multi-cloud federation, because many of these clouds belongs to different operators, maybe different countries and so forth. So there's another dimension here, multi-cloud federation, that also should be maybe considered here to simplify the management of these different clouds, to basically have a telco-grade cloud. So that's it. And final then, so here was a very quick overview what we're doing in the architecture working group. And so it's a bit summary. We want more model design of the network functions. We want to have some streamlining the functions. We want to enable several new services such as a service, ACAS, compute. We want to transform the cloud to telco-grade, and we want to improve the network's flexibility. Here you can see the deliverable with that I just presented. It's based, yeah, it's on our webpage. So thanks for me.